I'm happy to share with you the tech talk about key management for administrators. First off, what we are going to look at is current solutions of key management integrations into the HSM. The second part will be demonstrating the key manager user interface, which we have built just recently. Followed by a little architecture slide, so how things are working. It's getting a little bit more technical there, and followed up ending with a little roadmap, so where are we going? First, what are current key management integrations into the HSM? We have very classical ones, which you may already have used, things like Primus tools, a Java-based CLI command line interface tool to manage cryptographic keys on the HSM. Secondly, we have lately introduced adapters for HashiCorp Vault or OpenBOW secrets management, which is a very practical and handy way of managing HSM keys, but not only that. We are focusing on managing HSM keys, and with that, a couple of custom solutions by our engineers or engineers in general have been implemented, but they are very use case specific. Most of the time, they solve a particular problem where PKI systems come into place for certificate management, other secrets engine, things like database encryption, which they themselves call key management systems as well. What they do is most of the time having software-based keys, and they use HSM keys, RSA EC, for key wrapping and unsealing with that. So what the key manager user interface is all about, it's about managing cryptographic keys only on the HSM. So there are no software-based keys or file-based keys that are managed, very important. It is a little browser user interface integrated into the Securosys REST API and supports all functionalities of the REST API in general. It allows you to manage the entire key lifecycle from generation, storage, modification, rotation, what we have heard in the morning by Marcel, and decommissioning. Lastly, and there's where, or the reason why we have built a user interface is for managing key policies. Our patented or our solutions of smart key attributes to allow third-party or authorizers approve cryptographic transactions such as signing and decryption. It comes with a little approver management tool to onboard your authorizers, your approvers, and it allows you in a little dashboard to have a slight overview of certificates when they expire and so on. Very important, the certificates are not the ones you have in your PKI. These are the certificates you store as objects on the HSM next to your private keys. So the role of the key manager user interface, and this is very important, is key administration. It is not usage. For usage, I would like to demonstrate a little bit more in an architecture view how the entire ecosystem in your enterprise landscape can look like. So imagine that a role in your organization with as a key administrators authenticates against the identity access management or identity provider, such as Microsoft Active Directory, GitHub, Okta, Keycloak, we all know that. So an authenticated user logs in, authenticates against the key manager user interface in the browser, which is integrating into the REST API, knowing our provider concept. We saw that in the morning a little bit. PKCS11 has a provider which is embedded in the application. With REST API, we have it as a service or as an endpoint directly. So the key manager or the key administrator can manage keys in multiple HSM partitions. You want to segregate these keys, so you don't want your PKI root keys next to your database encryption keys. So you can actually manage multiple partition and the keys are shown. Now, this is all key administration. Key usage is where our applications or the applications we have been integrating with or partners have been integrated into us for the key usage. So things like web server, Nginx, Apache, OpenBOW solutions, or even databases are using the keys generated by the key manager user interface using the standard providers such as JC, PKCS11, or Microsoft CNG for Microsoft applications. New to this family of providers, we have worked hard in the last year to allow and to adapt into OpenSSL's v3, the provider concept, and newly added KMIP, Key Management Interoperability provider support. Like to show the key manager user interface based on a little sample. We are first of all setting up the authorization app in order to approve mobile-driven authorization using smart key attributes. Secondly, we are creating an issuing key which has a smart key policy onboarded, meaning the authorization app. Next, we are creating a web server key and a certificate signing request for this web server, with which we are issue a certificate signed by our root key. So that's the key manager user interface as it is. It provides possibility to configure the REST API's endpoint and allows authorization or access with this password. It is possible to set up multiple roles like key management, approver management, or service role. The service role in particular is used to show the dashboard's contents, things like for what vendor we are signed up, what partition we are connected to, the REST API's version. Additionally, we have a little graph which shows us the storage capacity as well as licensed features. To continue our sample, we are setting up the authorization app, so my mobile application. I will go to SKA approver and I will just re-onboard this approver again. So I can click renew OTC, which stands for one-time code. I have a QR code, which I can then scan with my authorization app. On the right side, we have the authorization app onboarded or displayed. And the first thing I have to do is to set my backup password. So the authorizer or the approver is protected by a password, and this is the password I'm going to enter right now. Okay, I have set my password and I'm going to scan the QR code. After scanning, my application will get redirected and I have successfully onboarded my approver called finance officer at securosys.com connected to this endpoint here. Next, we are heading to our keys dashboard and we are going to create a new key. The key we are going to create is the root key or the issuing key. So we call it SUDC 2025 issuing key. We have capacity or possibility to select the algorithm family, or say EAS elliptic curves or PQC keys are available. Basically all the algorithms that the REST API natively supports. For that case, we are creating a elliptic curve key and selecting the curve to be used. The manager UI allows me to specify the key attributes. Our key will be used to assign other certificates. This is the purpose of the issuing key. So the only purpose or the attribute capability we define and set is signature. For this key, we are adding a authorization policy, and inside my authorization policy, I'm going to onboard the previously registered finance officer at securosys.com. I can go ahead and create this key, which I then get a confirmation, okay, this key has been created. So let's check if this key has actually been created by filtering for this key, and we see, all right, there is a entry. By clicking on it, we see certain attributes of this key, things like what algorithm it is and what's the public key. Currently, there is no certificate assigned or assigned to this key. That's what we are going to do in a later step. And to conclude this little dialogue, we do have possibility to check the attributes, to verify the smart key attribute policy, where we can find our finance officer, securosys.com, and even create an attestation so we can prove the origin of this key being stored in the HSM. The next thing is to self-sign this, to create a self-signed certificate for this key with a validity of 10 years. The signature algorithm will be SHA-256 with ECDSA, and the key usage will be key cert sign only. This key will be or will act as a certificate authority, whereas it is not really a certificate authority. Nevertheless, we are going to create a certificate, and because this key has smart key attributes or is protected by smart key attributes, we are seeing this little weighting diagram. On our authorization app, if we hit refresh, we do see the approval challenge popping up, and we can check the content of the request to be approved by our mobile application. After verifying it, we can click approve, and the authorization has been passed to the REST API. The Key Manager user interface recognized that the approval, all necessary approvals have been collected and issued this certificate. We can now even see in the keys attribute that the certificate has been imported into the HSM. We have capabilities such as download certificate, see the validity period, and so on. The next thing is creating the web server key. So we click the button, create new key, call it SUDC 2025 web server key. This will be a key from elliptic curve as well, the same curve. And for that one, we're gonna select as well only signature, the capabilities to only sign things. For the web server key, we are not adding a SKA policy, because if, for example, you have a TLS connection, you don't want to approve every TLS connection every time, rather have the handshake done automatically.
We are going to create that key and have again a confirmation that our key has been created. The entry is populated right away, and we can go ahead and issue or generate our certificate signing request. Again, the signature algorithm will be SHA-256 with ECDSA. We can set a common name, web server securosys.com, setting an organization or a country, as well as a state or province. This key will be used for digital signature, key encipherment, server authentication, or any other possibility from the dropdown. After clicking Generate CSR, we get the prompt that a new certificate signing request has been generated, and we can copy it conveniently from the to the clipboard. Our issuing key will now sign this certificate signing request by clicking Issue Certificate. We're going to paste the payload from our clipboard into the CSR form, and we can even override what the common name shall be, securosys.ch, for example. Validity as well as signature algorithm, I am fine, and I can issue this certificate. So what's happening here is we are signing this CSR with our issuing key. Remember, the issuing key has smart key attributes, so an approval is required. Back again, or back to our authorization app, we do see that we find a signed certificate approval request. We do see for what key usage this CSR or the certificate shall be used, and we see for what web server the request is issued. After clicking Approve, the key manager user interface will wait for the next 5 seconds and then continue to process the certificate issuance. Again, copying the X509 payload to the clipboard and continuing by importing this issued certificate into the HSM. We do have now the certificate imported, and we can verify whether this certificate has actually been attached to the key. And we do see that the subject is web server securosys.ch issued by our issuing key.
Going to
with that, I'm done
support
with my
further
demo.
adapters in hyperscalers for bring your own key use cases for GCP, AWS, and Azure. Identity provider support to have a managed identity and log into the key manager UI will be added as well. We are planning to create profiles for these key policies, because organizations have quite strict rules, and a finance officer or a CEO will be predefined as profile, which can be attached to the key directly. The BSI requirements, a paper which we were involved in, we will follow, and it's a paper from 2025 key management system requirements, whereas this is not a fully fledged key management system solution. We are very open for further ideas and would love your feedback in general. And to close and round this a little bit up, again, so what are the benefits? What are the takeaways? It is a key management user interface to securely generate, store, rotate, and decommission cryptographic keys. The HSM acts as a root of trust, meaning all keys loaded in the user interface are not cached. There is no database required. It is the HSM which is delivering all the details which are presented. So you don't need to worry about any database backups, whether they are encrypted or not. It's a very lightweight solution with only 10 lines of configuration to deploy it in your infrastructure to manage your keys. It supports SK policies and approver management with the QR code being scanned. Exactly. It has multi-tenancy support. It allows you to connect to multiple partitions and identity provider, which are used for authentication. With that, I thank you very much for listening and looking by. Thank you.
Thank you, Sebastian. Any questions? I have two questions. Is there a transaction security broker integrated, or was that behind it? Which is in here?
What we just saw with the approval, waiting, and I think that's exactly transaction security broker for issuing certificates.
Yeah, and that's still an external system that was just invisible in the day.
It's building on top of it, exactly.
So it's integrated in the key matcher.
Most people confuse REST API and transaction security broker. It's just a license feature. It's the same into REST API transaction security broker integration.
And this morning it said that you can integrate the TLC.
Yeah.
It's just a question if I have to deploy two systems or
no, you don't. It's the same. Yeah.
And the second question is regarding the multi-tenancy. For multi-tenancy, I need multiple users. Is that required, or can I do multi-tenancy with just one user behind?
So a user equals one partition.
Yes.
And there are multiple partitions required. Yes. To segregate. Exactly. You can, with the token or JTT token you saw, can connect to multiple partitions, right? And then it's loading the key information from the partition directly.